There are three charges q each placed at the vertices ABC of an equilateral triangle. We need to find the net force on charge at each vertex. If a charge small q is placed at the centroid of the triangle, what is the net force on this small q? There are three charges, capital Q, each placed at A, B, and C, the three vertices of an equilateral triangle. Now the sides are equal, that is L each for the sides. Angle is also equal to 60 degree. Since all the three charges are positive, they mutually repel. If you take charge at A experiences a repulsive force due to B. So charge B repel A along this direction. This is a force on A because of B. Same time A is repelled by C also. Both C and A are positive charges. C also repel A. If you are finding the net force on A, consider in which direction A is supposed to move. So because of B, A is supposed to move here. Because of C repulsion, A is supposed to move here. FAC and FA. Both forces are equal in magnitude since the distance and the charges remain the same. Since forces are equal, the resultant force will be always along the bisector. So since an equilateral triangle is 60 degree, this angle also 60 degree vertically opposite, the resultant force will be making 30 degree with FAC and FAB along positive JK. Same way, if you take C, now you are finding force on C. So imagine where C is supposed to go because of A and B. A will repel C, so this is FCA. C will go towards B, towards right because of B, only if B is acting. The resultant of that will be again 30 degree with FCB and FC. Same way B also experience repulsion from A, that is force on B due to A. Same way B experience repulsion due to C also, FBC equal 60 degree, resultant will be 30 degree with FBC and FB. So all the cases the resultant is along 30 degree with the other two forces. Only thing is to find the magnitude. Finding the magnitude, we need to find FAC and FAB as a sample. So FAC and FAB both are equal using Coulomb's law, K, Q into Q square by L square. The magnitude of all the forces FAC and FAB remains same. Just for convenience of calculation, we call it as F. The angle between FAC and FAB is 60 degree. Since these two are vectors, using vector addition, the resultant of FAC plus FAB will be root of FAC square plus FAB square plus 2 FAC FAB cos theta, cos 60. For easy calculation, FAC and FAB is taken as F. The resultant force will be, instead of FAC F, FAB also F. So FAB into FAC will be F square cos 60. Cos 60 is sin 30, 1 by 2. So 2 to get cancelled. So 3F square inside the root. So F will go out root 3F. So the resultant force will be root 3 times of force on 1. F is equal to KQ square by L square. You can substitute here. The resultant force will be KQ square by L square, 30 degree with FAC and FAB in this particular case along with it. Same way, all these forces will be, FC also will be root 3 KQ square by L square along 30 degree with FCB and FCA. Same way FB also. So that's a force, net force on each charge at the vertex. Now we need to find the force on a charge at the centroid. If we keep a fourth charge at the centroid, small q at D, now this D experience force due to all the three charges on the vertex. A will repel B, the charge small q. The small q have a repulsion downward. So as before, which charge you are considering? Just imagine the movement of that particular charge. Means don't check whether A will go up or down, because your interest is not A. Since you are finding force on D, the small q, just imagine where the small q is supposed to go because of A, B and C. So A and D both are positive, both will repel. A will go upward, D will go downward, but our interest is D, so D is downward. That's along minus J cap. This is FDA, force on D due to A. Same way C also repel D, so because of C, it will be repelled from D towards this direction. That is force on D because of C. Same way FD, B will be away from the line joining D to D because it's repulsion. This equilateral triangle, this is 60 degree, the vertical, the opposite angle will be 120 degrees. So for these are equally spaced, the angle will be 120 degrees. Each of the forces FDB, FDA, FDC all make 120 degrees. Now to find the resultant, we need to find sum of any two. That resultant must be added with the third one. We are finding FDC and FDB first. So all the three, the forces, all the three are equal in magnitude because the distance A to D, B to D, C to D just marked as X remains same. The charges are capital Q and small q. So AQQ by X square, the distance from A to D, B to D and C to D all are X, the charges are Q and Q. This is a magnitude but directions are different. Now if you are adding FDC and FDB, FDC and FDB both are equal, we call it as F again, and the angle is 120 degree. So the resultant of FDC plus FDB using vector addition, FDA square, FDB square plus 2 FDA, FDB square, FDA and FDB which become F square. Angle between these two forces 120 degree, cos 120. Cos 120 is minus 1 by 2. So F square plus F square into 2F square into minus 1 by 2. So 2 to get cancelled, minus F square plus F square get cancelled, so F square just F. The resultant force will be just F. F is same as KQQ by X square. Since these two are acting 120 degree, the resultant of this will be marked as a green line along JK. So FDC plus FDB will be 60 degree with FDC and FDB, which is exactly same along the JK. So KQQ by X square is a net force that's acting along JK. Now we add FDC and FDB. Next one is we have to find FDA. FDA, it's acting vertically downward minus J cap. The force magnitude is KQQ by X square. So KQQ by X square along minus J cap. When you find the net force, you have to add all the three. So FD will be sum of FDA plus FDB plus FDC. This already you added. FDB plus FDC we have KQ square, KQQ by X square along J cap. And FDA we have KQQ by X square minus J cap. When you add two equal opposite forces, the net force will become